Hey everyone, Mr. Regan here, and today we're going to be looking at exploring a unique population of K-neck species as we look to understand how species are related to one another using an evolutionary tree. In the previous set of tasks, your job was to analyze this diagram to help us understand that among any three species, the two species that are separated most recently are the most closely related to each other. So when we look at our diagram here, if we're looking at descendant species A and B, we know that they're more closely related because they are more recently separated. A and B have been separated more recently by their descendant species number one, and that helps us understand that they're more closely related. And we can see that by their connection on the tree, looking at the lines and where they intersect. Whereas even though A, B, C, and D are all in the same place in terms of the column, compared to descendant species 1 and 2, compared to the ancestor population, even though they're on the same side of the diagram, their connection and when they were separated helps us to see they're more closely related. Just like if we're looking at descendant species 1, they are more closely related to descendant species 2 because that's where they are connected. They're also related to descendant species A and B, and that also helps us understand that connection we see in the lines helps us understand their relatedness. So today, we're going to dive a little deeper into this idea and use our K-neck species to help us understand our mystery fossil problem and to continue investigating our focus question. So our focus question is, when you compare different species, how can you tell which species are more closely related? And to do that, we're going to use these species. Similar to Legos, K-necks connect using different pieces in different ways. And we've created these little species here to help us understand and answer this question. So our K-neck species are obviously imaginary species that have been evolving for a long period of time and have structures that are represented by K-necks. So each of these are individual structures that when put together create the different species. Now, the species has been organized into this evolutionary tree that we see here. And we're going to be analyzing the relationships among these imaginary K-neck species. Remember, the more related they are is based on their connections in the tree. So let's take a deeper look at this tree. When we look at this tree, there's a bunch of things that pop out. Number one is the evolutionary time. If you look at our tree here, and at the very top, it shows that they've been evolving for 80 million years. And at each place in the tree, we see at what time different species showed up in the population, going all the way up to 10 million years to the present day, which are our last set of species. Our common ancestors all the way on the right. Our descendant species change over time, over those millions of years, leading to our final descendant species that we see in present day. We do have some species that went extinct. If you notice, species D and E both went extinct, and we know that because we don't see any descendant species connected from them, and none of their descendants are actually found in the 10 million year old present. We do have some missing species as well, A, F, and G. Those species clearly have missing structures in terms of what they would have looked like, and our job is to figure out, based on the shared structures that we have in all of our species within our evolutionary tree, we're going to need to analyze and figure out what is missing, who is missing, and so on. So your job as a paleontologist will be to analyze how closely these species are related to one another by collecting evidence in their evolutionary tree. We're then going to be completing the missing sections of this of their evolution. To do this, we're going to be making observations so that we can collect some data. We're going to be explaining who is more closely related within the tree, and then we're going to be creating models of what those missing species would look like. So in task 5, this is where you're going to collect your data and make some observations about what shared structures. There's going to be 5 questions here that are going to be asking about different shared structures that different species have compared to others on the evolutionary tree. So make sure you're detailed in task 5 when collecting your evidence. In task 6, this is where you're going to explain who's more closely related to who. So this is where you're going to need to use your shared structures, use those intersecting lines on your tree to help explain who's more connected to who. And then in task 7, that's where you're going to make your model. You'll notice that you'll have all these little K-neck pieces here, and you're going to have to build what the species looks like for species A, F, and G. You will use as many as you need, and you'll move them wherever you need as often as you want. You might have some pieces that you might not need. It all depends. So that's what our next set of tasks are going to look like. So ask yourself, do you understand how to analyze the K-nex evolutionary tree? And do you understand how to collect evidence, analyze their relatedness, and model the missing species? If the answer is yes, put your X in green. Otherwise, check in and good luck.